Hi, and welcome to Sleep Time Discoveries. Tonight, we're exploring one of the biggest questions humanity has ever asked, but in a way you might not expect. Every generation asks the same question, but maybe we've been asking it the wrong way. It's not just, are we alone? It's how could we be, in a universe with billions of galaxies, each holding countless worlds? When you think about it, the real mystery isn't whether life exists elsewhere. It's why we still doubt it. In this video, we'll explore some of the most fascinating and convincing theories that many scientists and researchers believe could explain the existence of alien life. These aren't wild guesses or fiction. They're ideas built on science, evidence, and the strange consistency of unexplained patterns across space and time. Each theory reveals something, a scientific clue, a mathematical probability, or an observation that challenges what we think we know about life itself. And as you listen, you might start to notice a shift, a quiet realization that the universe might already be full of life. Not in the way we picture it, but in ways that make the idea of alien existence feel less like a question and more like a certainty. Because what if the beings we've long called aliens aren't from another world at all, but from another time? Our own distant future. The time migration theory suggests that what we interpret as extraterrestrial visitors might actually be humans, evolved over millennia, coming back through the corridors of time. Think about it, those classic descriptions of aliens with large heads, small mouths, and slender bodies. They strangely resemble what evolutionary biologists predict humans might look like thousands of years from now. More brain, less muscle, bodies adapted for technology rather than survival. If time is not a straight line but a loop, then maybe these future versions of us found a way to bend it. Physicists have long talked about closed time-like curves, pathways through spacetime that could, in theory, allow travel to the past. The math doesn't forbid it, it just makes it extremely difficult. But what if a civilization, hundreds of thousands of years ahead of us, managed to master the laws we're only beginning to understand? Wormholes, quantum tunnels, manipulation of gravity itself. Perhaps time travel isn't fiction to them, it's science. Now picture this. They come not in invasion, but observation. Not to conquer, but to study their own origins. Maybe they're here to witness certain turning points, the invention of artificial intelligence, the beginning of interplanetary life, or the choices that determine whether humanity survives its adolescence. To them, we're living history, breathing data from a past they can't change, but can still learn from. Of course, this brings up paradoxes, the kind that twist your brain in knots. Could meeting one of these future humans alter their own existence? If a time traveler saves a person who was meant to die, does that rewrite their own timeline? Maybe they've already solved this, creating self-consistent loops where every action they take has already been accounted for. The universe, after all, might be more self-correcting than we imagine. It's an eerie idea, isn't it? The thought that those glowing crafts or fleeting lights in the sky might not be strangers. They might be us, looking backward across the ages. And yet, even if that's true, it leads to an even deeper question. If we can travel through time, if our descendants can manipulate the laws of reality, then maybe the entire universe, everything from time to consciousness, is far more structured than we realize. And that's where another idea begins to form. What if all of this, time, space, even life itself, is part of something built, something designed? Here's where things start to get seriously mind-bending. The simulation hypothesis suggests that our entire universe could be a kind of hyper-realistic simulation created by an intelligence far beyond our comprehension. To put it simply, we might be living inside a cosmic computer program. This isn't just a sci-fi fantasy. Philosopher Nick Bostrom laid it out with logic that's hard to dismiss. If technology keeps advancing, eventually a civilization could create incredibly realistic simulated worlds, ones that include conscious beings who think they're real. And if it's possible to do this, it's likely that countless such simulations would exist. So statistically, it's far more probable that we're inside one than the original base reality. Now, think about that for a moment. The laws of physics, the speed of light, the balance between gravity and electromagnetism, they're all perfectly tuned for life. Maybe that's not coincidence. Maybe those are the parameters chosen by the programmers. The Big Bang could have been the moment the simulation began. Dark matter might be the processing power we can't see. Quantum randomness could be the program's way of injecting unpredictability. And what about aliens in this framework? They could be the system's architects, or even higher-level beings in another layer of reality. If you stretch the idea further, they might be what ancient civilizations called gods. Not divine in the traditional sense, but creators operating from outside our simulated world. It's unsettling but fascinating. The idea that everything we know, from our thoughts to galaxies, could be code. Maybe those unexplainable phenomena, like déjà vu, quantum entanglement, or strange patterns in cosmic radiation, are glitches or updates. Perhaps those mysterious UFOs people report are maintenance drones, checking up on the simulation, adjusting variables, ensuring it stays stable. And if that's true, it could explain why the universe seems so quiet. Maybe we're not meant to find other life because the parameters haven't been written for that yet. Or maybe the simulation is running a test, seeing how long it takes a species to realize what it's inside of. It's both terrifying and strangely comforting to think that behind all this randomness might be purpose. If the universe is a simulation, then nothing is meaningless. Every action, every discovery, every spark of consciousness might serve a design greater than ourselves. But suppose we are real, truly physical beings in a real universe. Then the silence of space remains one of the greatest mysteries of all. If intelligent life exists elsewhere, why haven't we heard from them? Maybe they're avoiding us. On purpose. The zoo hypothesis offers a surprisingly elegant answer. Advanced civilizations might already know about us. They just choose not to interfere. Think of humanity as an emerging species inside a cosmic nature reserve. We're being observed from a distance, monitored quietly, allowed to evolve without interference, much like animals in a protected ecosystem. This idea reframes the so-called Great Silence. The lack of alien contact doesn't mean we're alone. It might mean there's a rule, a kind of galactic non-interference policy. To us, the universe seems silent, but maybe it's only quiet because others are listening carefully, ensuring we don't realize they're there. If true, it would mean that our planet, our technology, and even our attempts to send messages into space are already known to others. Perhaps they've been watching our radio signals for decades, analyzing our behavior, waiting until we're advanced and peaceful enough to meet. In this context, UFO sightings could be probes or drones, quietly gathering data, but never making open contact. Imagine the ethical challenge for these civilizations. To them, we might look like a young, chaotic species, still prone to conflict, still struggling to unite. Revealing themselves too early could change everything about our development, our religions, our governments, even our sense of purpose. So instead, they stay hidden, studying our progress, waiting for the right moment. It's a strangely comforting thought, that the silence might not be emptiness, but protection. Maybe, in their eyes, humanity is part of a grander experiment, one that requires patience before graduation. Perhaps the day will come when we finally send the right signal, or show the right maturity, and the silence will break with a simple, universal message. You're not alone anymore. But maybe the reason we haven't found them isn't philosophical or ethical at all. Maybe it's chemical. Maybe life doesn't look like what we expect it to. Almost every search for life beyond Earth assumes one thing, that it will be carbon-based, like us. After all, carbon is flexible, bonding easily to create complex molecules, the foundation for everything alive on Earth. But what if that assumption blinds us? What if intelligent life elsewhere is built from entirely different chemistry, silicon, ammonia, or even plasma? Astrobiologists call this the non-carbon life hypothesis. It's the idea that the universe could be teeming with forms of life that our instruments simply aren't designed to detect. We're looking for water when they might breathe methane. We're searching for warmth when they thrive in ice. Our telescopes analyze atmospheres for oxygen, but other life could use completely different gases. Take silicon, for example. It's abundant in the universe and can form long molecular chains similar to carbon. Silicon-based life could exist on hot, rocky worlds with bodies made of crystal-like structures instead of flesh. Their perception of time, motion, and even light might be drastically different, their world unfolding in slow, shimmering patterns rather than quick biological reactions. Or imagine ammonia-based life thriving in frozen exoplanets where temperatures plunge far below zero. These beings could move sluggishly through liquid ammonia seas, communicating chemically rather than vocally, existing in a state so alien it would defy our imagination. Then there's the boldest idea of all, plasma-based intelligence. Life that exists as electromagnetic fields within stars, nebulae, or even gas giants. They wouldn't build machines. They would be the machines. Self-sustaining networks of charged particles, thinking in frequencies and light. If life like this exists, it would explain a lot. Our sensors, built for carbon and water, would never detect them. We could be surrounded by forms of consciousness completely invisible to us, forms that see us as strange, fragile creatures made of dust and liquid. And maybe, just maybe, they're aware of us. Not as equals, but as curiosities in a cosmos much broader than we ever imagined. It's humbling to realize how narrow our definition of life really is. Every telescope, every probe, every experiment is calibrated for our kind of biology. Yet the universe may not share our preferences. It may favor diversity beyond comprehension, a living cosmos filled with beings who don't look, move, or even exist the way we do. And when you put all of these theories together, the travelers from our future, the possibility that reality is simulated, the watchers who choose silence, and the forms of life completely outside our comprehension, you start to see a pattern. The story of aliens isn't just about others. It's about us. It's about how we define life, consciousness, time, and the very structure of reality. Maybe the reason we haven't found aliens yet isn't because they're absent, but because they're everywhere, in forms and dimensions we're only beginning to imagine. Whether they're future versions of ourselves, architects of our universe, patient observers, or hidden chemistries in distant worlds, the message seems the same. The universe is alive with possibility. And the more we search, the more it feels like we're on the edge of a truth too vast for words, one that quietly whispers, "We are not alone." Before we dive deeper into the mysteries of extraterrestrial life, let's consider that the universe might be speaking in languages we haven't yet learned. Perhaps the signals are there, but we're just not tuned in. And even beyond that, there are secrets hidden in the very way life evolves and the strange structures in our own celestial neighborhood. Let's explore these possibilities one by one as they challenge the way we see intelligence, life, and the cosmos itself. What if the reason we haven't made contact isn't that aliens don't exist, but that they communicate in ways that are completely alien to us? That's the essence of the communication mismatch hypothesis. For decades, SETI, the search for extraterrestrial intelligence, has focused on radio waves. We point our antennas at the stars, hoping to catch a signal, and yet, in 60 years of searching, the cosmos has remained almost eerily silent. But consider this. Maybe radio waves are just primitive. Perhaps the civilizations capable of interstellar communication have moved beyond such crude tools. They could be sending messages via neutrinos, those almost massless particles that pass through matter effortlessly. Or perhaps gravitational waves, ripples in space-time itself, carry subtle patterns that could encode vast amounts of information. Even more astonishing is the possibility of quantum communication, where information can be entangled across distances faster than light. From our perspective, these methods would be invisible. Our detectors are tuned to carbon-based life, visible light, and electromagnetic signals. But the universe may be humming with information we can't perceive. Every UFO report, every unexplained anomaly might just be a clue that the cosmos is speaking, in a language we've yet to decode. The implications are profound. If advanced civilizations find radio primitive, then our attempts to listen might be like holding up a tin can to catch a symphony. They could be aware of us, sending subtle nudges, testing our ability to comprehend while we remain oblivious. And this raises another intriguing point. Maybe their signals are already reaching Earth, hidden in plain sight. Mathematical constants in cosmic radiation, patterns in neutrino detectors, or fluctuations in quantum noise that we've dismissed as background interference. So the silence isn't necessarily absence, it's a signal we haven't learned to read. It's a reminder that intelligence might operate on levels far beyond our imagination, and that understanding it requires more than curiosity. It requires evolution, technology, and an openness to ideas that challenge every assumption we hold about communication. And speaking of evolution, if communication itself takes forms beyond our comprehension, perhaps life too follows a timeline we're only beginning to understand. Not everything has reached maturity at the same cosmic pace. Here's a fascinating concept. Intelligence doesn't spring up overnight. Life, as we know it, took billions of years to reach a point where consciousness could ponder the stars. That's the core of the evolutionary speed limit theory. Earth is 4.5 billion years old, yet intelligent life only emerged in the last few 100,000 years. In cosmic terms, we are extremely early developers. This has a striking implication. Alien civilizations might be developing all around us, but just not yet at a level we can detect. Planets that formed billions of years after ours could still be in their biological adolescence, evolving simple life forms that have yet to spark curiosity, culture, or technology. Our assumption that life should be everywhere now is a product of impatience, not probability. And it reframes the Fermi paradox, the puzzling silence of the universe. If civilizations are constrained by evolutionary timelines, then the galaxy is teeming with life, just not life we can recognize. In this light, every uninhabited exoplanet we observe might host microscopic organisms, slowly inching toward complexity, destined to eventually create their own telescopes, their own radio waves, and perhaps their own questions about the cosmos. Think about it. Intelligence requires stability. Planetary climates must be steady for billions of years. Cataclysmic events like asteroid impacts, supernova radiation, or star instability can reset progress. Our own history is a testament to that fragility. If evolution has a speed limit, then our seeming uniqueness might simply be a timing issue. We are early, yes, but patient observation shows that the universe's story is still unfolding and many chapters remain unwritten. And if we pair this with the communication mismatch hypothesis, a striking pattern emerges. Life may exist in abundance, yet we perceive silence because it hasn't reached a detectable level, or it speaks a language we cannot yet interpret. The cosmos could be alive with emerging civilizations, humming quietly in the background, patiently awaiting the moment they can join the interstellar conversation. But what if life's signs are hidden not in timing or communication, but in the very architecture of the moons and planets around us? Sometimes, evidence of alien ingenuity may be closer than we think. Take a look at the moon. It stabilizes Earth's rotation, moderates tides, and reflects sunlight in a way that feels almost deliberate. The artificial moons hypothesis proposes that some moons, perhaps even our own, could be the product of ancient alien engineering. Far from being natural satellites, they might be observation posts, energy collectors, or even remnants of a long-forgotten civilization. The theory stems from some curious observations. Our moon is unusually large relative to Earth, orbiting in perfect tidal lock. Many exoplanets have moons positioned in ways that defy conventional gravitational expectations. Could these orbits be designed, rather than random? And what about internal structure? Hollow moon anomalies have been theorized, suggesting that beneath the surface may lie cavities far larger than natural formation processes would allow. If an advanced civilization wanted to monitor the cosmos, planting artificial moons would be an elegant solution. They provide a stable, long-lasting platform powered by nothing more than orbital mechanics, capable of scanning planets, transmitting energy, or simply observing civilizations over millions of years. And while most of this remains speculative, it aligns with a broader pattern we see in astronomy. Structures and orbits that seem too orderly, too purposeful to be purely coincidental. Consider how life and intelligence evolve. A species capable of interstellar travel might leave behind silent sentinels disguised as natural objects, waiting for their creators to return or simply recording the evolution of younger worlds like ours. And if we broaden this beyond our moon, other satellites in the solar system, the icy moons of Jupiter and Saturn, could also conceal artificial elements, subtly influencing or observing life below their frozen surfaces. And yet, if life is as pervasive as we suspect, perhaps it isn't just hidden in moons or planets. Maybe it travels, carried across the stars themselves, planting seeds of life wherever conditions allow. The panspermia theory offers a mind-expanding perspective. Life may not have originated exclusively on Earth. Instead, it could have traveled between planets and even star systems, hitching rides on comets, asteroids, or dust particles. Organic molecules, including amino acids, have been discovered in meteorites like Murchison, hinting that the building blocks of life are spread throughout the cosmos. If this is true, then life on Earth may be part of a much larger story. A single chemical spark, created elsewhere, could have seeded multiple worlds, allowing evolution to unfold independently in countless locations. And in this sense, alien life might not be a distant other, but a sibling, part of the same cosmic family tree branching off across galaxies. Panspermia doesn't just suggest passive transport. Directed panspermia, an extension of this idea, proposes that some advanced civilizations may have deliberately sent life to new planets, seeding them intentionally. While this remains speculative, the implications are staggering. Perhaps life on Earth is not an isolated miracle, but a chapter in a vast narrative of biological experimentation conducted on a galactic scale. And even if life didn't arrive via deliberate intervention, the sheer probability of organic molecules spreading through space indicates that habitable planets might be more common than we imagine. Each comet that passes near a star could be a delivery system, each asteroid a tiny ark carrying the potential for new beginnings. When you combine the communication mismatch, evolutionary speed limit, artificial moons, and panspermia theories, a remarkable picture emerges. The universe might be simultaneously alive, intelligent, and interconnected, yet in ways we can barely perceive. Life could be whispering across the stars, evolving at its own pace, leaving subtle clues for those who know where and how to look. But maybe there's another reason this vast web of life feels so quiet. Maybe it isn't that civilizations aren't out there. Maybe we simply can't reach them, not because of distance, but because something in the fabric of reality itself keeps us apart. Let's go deeper. Imagine a universe partitioned by invisible walls, not political borders or interstellar distances, but natural boundaries set by physics itself. The light barrier theory suggests that we might be living inside one of these cosmic enclosures, a locked region of space cut off from others by insurmountable energy limits. We know that nothing can travel faster than light. That's one of the oldest and most stubborn rules in physics. It defines the cosmic horizon, the edge beyond which information can never reach us. There are galaxies so far away that even their light will never arrive, no matter how long the universe lasts. To us, they simply vanish beyond time's reach. But what if this isn't just a coincidence of distance? What if the light speed limit is part of a larger structure, a kind of containment field woven into the universe itself? Some physicists have speculated that regions of the cosmos may be defined by differing densities of dark matter or dark energy, enormous gravitational bubbles that bend space-time in subtle, isolating ways. Inside each bubble, the laws of motion might appear normal, yet crossing from one to another could require energy far beyond any civilization's reach. It's a haunting thought. Intelligent species could thrive in their own local universes, evolving, exploring, even searching, but forever separated by this cosmic quarantine. From their point of view, we would be the unreachable ones. The silence between galaxies wouldn't be due to apathy, but architecture. And then, there's an even stranger twist. What if these barriers shift? What if regions of the universe expand or contract over time, creating windows of connection that appear for only brief cosmic moments, epochs where light, gravity, and information can leak through before the walls close again? Civilizations might arise, send out a surge of communication, and vanish behind the curtain before anyone hears their call. In that light, our era could be one of isolation, a quiet pocket, waiting for physics itself to evolve. The only way through may not be technology at all, but a new understanding of energy, matter, and space-time. Until then, we might remain inside our cell, gazing at a universe full of potential neighbors we'll never meet. But not every theory keeps those neighbors locked behind physical limits. Some ideas suggest they're already here, not from far across the galaxy, but from a reality layered right on top of our own. Now imagine this. What if extraterrestrials don't come from distant stars at all? What if they come from elsewhere? Not another planet, but another plane of existence entirely. That's the idea behind the interdimensional being theory. For years, some UFO encounters have shown physics-defying behavior, objects that accelerate instantly, make right-angle turns, or vanish in silence. These don't fit our understanding of propulsion, gravity, or even inertia. Some researchers have speculated that what we're seeing could be the bleed-through of parallel dimensions, brief overlaps where beings from another reality intersect with ours. Modern physics doesn't rule out extra dimensions. In fact, string theory predicts up to 11 of them, folded tightly within the fabric of the universe. If life has evolved to exist within these hidden dimensions, it might have the ability to traverse between them, slipping in and out of our perception like reflections on rippling water. Think of it like overlapping radio channels. We exist on one frequency, while other intelligent beings occupy adjacent ones. Every so often, the signals distort and overlap, a flicker in the sky, a flash of motion, a mysterious radar return that appears and disappears. To us, these moments look like anomalies. To them, we might appear as ghosts. If true, it would explain the strange inconsistency of sightings across history, why they seem to appear selectively, why their behavior often seems observational rather than invasive. They may not travel through space as we know it, but rather phase through layers of reality, visiting worlds stacked side by side with ours. And maybe, just maybe, this is what ancient cultures sensed when they spoke of gods descending from the heavens, or spirits walking between worlds. Perhaps they were witnessing the same phenomenon, dimensional travelers briefly crossing the threshold. To us, such a theory sounds extraordinary, even mystical, but in a universe defined by quantum uncertainty and hidden dimensions, extraordinary may simply mean underexplored. What feels paranormal today might one day be the physics of tomorrow. Still, even if some beings can cross dimensions, another possibility lingers in the background, one far darker and perhaps far more probable. It's not about barriers or hidden realities. It's about survival itself. This one hits close to home. The Great Filter. Theory proposes that intelligent life tends to destroy itself before it ever reaches the stars. Somewhere along the evolutionary path from primitive to advanced, there's a bottleneck, a hurdle so catastrophic that almost no civilization survives it. When we look at the history of our own planet, it's hard to dismiss the evidence. Earth has endured at least 5 mass extinction events. Each one nearly erased life entirely, wiping out 90% or more of species. Yet somehow, each time, life rebounded. Humanity itself has come close to collapse more than once, through climate change, nuclear tension, pandemics, and now, the accelerating instability of our own technology. If every planet that produces intelligence must pass through similar trials, then perhaps very few ever make it to interstellar maturity. Some might destroy themselves through war or resource collapse. Others might fall victim to runaway artificial intelligence or ecological disaster. In that sense, the silence of the cosmos may not be peaceful, it may be tragic. Maybe we don't hear alien voices because those civilizations never lived long enough to build lasting beacons. Their signals fade quickly, just as ours one day might. The galaxy could be littered with the ruins of failed attempts, silent worlds once vibrant with life, now frozen monuments to ambition gone wrong. And here's the uncomfortable question. Where are we on that timeline? Are we before the filter, standing on the edge of self-destruction? Or have we already passed it, the rare few who survived by chance or foresight? The answer could define our destiny. If we're before it, then our greatest responsibility isn't exploration, it's survival. to ensure that when others finally emerge, we're still here to greet them. And if we've already passed it, then our existence is even more remarkable, a proof that the great filter isn't absolute, that intelligence can endure. But what if survival doesn't just mean making it through? What if, out there, countless civilizations have survived, yet they all made the same terrifying choice: to hide? Picture a vast cosmic forest, stretching endlessly in every direction. Every civilization, every planet capable of thought, is like a hunter moving silently through the trees. Each carries a light, but no one dares to ignite it. Because in this forest, every glimmer, every sound, could mean death. That's the chilling premise of the dark forest hypothesis, one of the most haunting answers to the Fermi paradox. It suggests that the universe is teeming with life, but that life has learned to stay quiet. Because in a cosmos without universal law or protection, the first to reveal itself might also be the first to disappear. The logic is brutal but simple. Every civilization has two basic truths. It wants to survive, and it can't know the intentions of others. Communication becomes a gamble. Announce your presence, and you might be inviting a predator. Stay silent, and at least you remain unseen. It's a theory inspired partly by physics and partly by human history. Look at Earth's own story. Whenever two isolated cultures made first contact, the less advanced often didn't survive the encounter. So, if a civilization capable of harnessing entire stars hears a faint radio ping from a primitive world like ours, what might they do? Curiosity or caution? For over 60 years, SETI has been listening for alien signals, yet not one clear message has ever been confirmed. Some scientists, like Stephen Hawking, warned against sending out our own broadcasts, arguing that shouting into the dark could be a fatal mistake. And that silence, that eerie absence of noise in a universe so large, might not be emptiness at all. It could be fear. Now, imagine that across the galaxy, thousands of civilizations exist right now, each one listening, each one aware that others could exist, and each one choosing not to speak. The cosmic forest stays dark, not because it's empty, but because every thinking creature knows it's safer that way. It's a terrifying idea, but an oddly logical one. The quiet of the stars might not mean loneliness. It might mean everyone's hiding. But then again, what if they're not hiding out of fear, but waiting? Not gone, not extinct, not silent forever, just resting. If the dark forest is about survival through silence, the aestivation hypothesis is about survival through patience. It proposes that the most advanced civilizations in the universe might not be dead or missing, they're simply asleep. The word aestivation means a kind of long hibernation during hot conditions, like how certain animals sleep through summer heat. Applied cosmically, it means that advanced beings could be waiting for the universe to cool down, to a point where running massive computations, building vast digital realities, or manipulating matter on a galactic scale becomes far more energy efficient. It's a concept proposed seriously by researchers from Oxford University in 2017. Their reasoning? If intelligence can think on cosmic timescales, it might realize that acting now, when the universe is still warm, wastes energy. The colder the cosmos gets, the more efficient information processing becomes. So, why not wait a few trillion years? It's an almost unsettlingly logical idea, a kind of galactic minimalism. Don't conquer the stars. Just rest, store your knowledge, and wake up when physics itself is cheaper to use. If that's true, then what we call the Great Silence might not be the sound of absence, but of slumber. Think of it like a cosmic winter nap. Somewhere, hidden behind vast clouds of gas and dust, there could be ancient machines, sleeping planets, or data vault civilizations lying dormant, surrounded by layers of protective energy fields. Their lights are out. Their signals stopped eons ago. But inside those vaults, minds may be dreaming, waiting for the dawn of a colder, quieter universe. And the fascinating part? This theory gives us a strange sense of hope. It doesn't say life failed. It says life is smart enough to wait. And maybe one day, long after our stars have faded, those beings will reawaken. curious to see what new species survived the heat of the beginning. But if some civilizations hide out of fear and others sleep for efficiency, there's another possibility. What if the most advanced ones haven't gone silent or dormant, but simply invisible? This one steps straight into the frontier of astrophysics. The gravitational veil theory suggests that intelligent civilizations could deliberately cloak their worlds, not with camouflage paint or stealth tech, but by manipulating gravity itself. To understand it, imagine this. When a massive object bends space-time, light passing near it curves. We see this happen naturally with stars, black holes, and galaxies. It's called gravitational lensing. Astronomers use it all the time to study distant objects that would otherwise be hidden. But what if a civilization learned to control that effect? If they could generate intense, localized gravitational fields, they could distort the path of light around their planet, effectively bending it away from our view. From a distance, their world would appear perfectly normal, or maybe even empty. No reflection, no emission, no infrared heat signature. Just gone. It's not as wild as it sounds. Several exoplanets already show strange light curves, gravitational patterns that don't quite fit known models. Some scientists blame binary stars or dust rings, but others quietly wonder if something artificial might be behind those distortions. After all, if we were capable of hiding from other eyes, wouldn't we do the same? Consider this. As our own detection technology improves, we're beginning to peer into exoplanet atmospheres, mapping chemical signatures that could hint at life. Any civilization aware of that might choose to remain hidden. Bending light isn't just about vanity, it's survival through invisibility. There's also a poetic elegance to it. A species advanced enough to manipulate gravity would have mastered one of the fundamental forces of nature, not just for travel, but for concealment. It's the ultimate stealth. You wouldn't need to leave your star system to be safe. You'd just need to vanish behind the universe's own laws. And maybe that's why, when we stare at the vast blackness between stars, we see only the faint glow of dead worlds. The living ones could be right there, hidden behind a veil we can't yet lift. So if we put all this together, the fearful silence of the dark forest, the cosmic patience of aestivation, and the invisible civilizations hidden behind gravitational veils, the universe starts to look less empty and more strategic. Maybe the reason we haven't met our cosmic neighbors isn't that they're gone or uninterested, it's that they're far wiser than we imagine. They've learned that survival among the stars means discretion. To exist is one thing, but to endure, you sometimes have to disappear. Maybe that's why, when we finally look past the silence and the shadows, another idea begins to form. One that's not about who's hiding now, but about who might have already come and gone. Because if civilizations can vanish, maybe some have already left their mark. Not in radio signals or greetings across the stars, but in the ruins they've left behind. That's where the galactic archaeology theory comes in. It's a simple but haunting concept. Maybe we're not the first, and maybe the proof of that is already scattered across the galaxy. In dead systems, shattered planets, or the strange metallic remnants of once thriving worlds. Imagine astronomers peering through their telescopes, not just looking for new worlds, but for old ones, scarred by fire, stripped by time, their surfaces glittering with unnatural alloys. When we observe older regions of the Milky Way, we're essentially looking into the galaxy's ancient neighborhoods. Those stars have been burning for billions of years longer than ours. Statistically, if life can evolve here, it could have evolved there, and possibly ended long before we arrived. Some researchers have even started referring to this as cosmic archaeology. Instead of bones and pottery, they search for debris fields or technosignatures like unnatural metal ratios, geometric orbital fragments, or even Dyson-like structures partially disassembled by entropy. There's something eerie about that. The idea that a dead system we catalog today might have once been bustling with life. A planet boiled down to ash around a fading star, a sphere once covered in oceans now orbiting as a hollow shell. These could be ruins, not just random accidents of physics. The evidence isn't clear yet, but hints exist. Astronomers have found white dwarfs, the burned-out cores of stars, surrounded by rings of metallic dust rich in elements like nickel and chromium that don't naturally appear in such quantities. These could be the remains of planetary crusts or even infrastructure that was once engineered. And when we find exoplanets with odd reflectivity, surfaces that shine too evenly or glint like polished metal, we have to ask, are we seeing nature or the remains of someone's creation? There's a certain melancholy in that possibility. Because if that's true, then much of what we're discovering isn't the future of alien life. It's the past. We might already be studying the ghosts of civilizations that reached the stars long before us, only to burn out quietly. And that leads us to something even more intimate, the idea that some of those ancient relics might not just be out there among distant stars, but already here, drifting through our own solar system. That's the technological relic theory, the notion that alien technology, billions of years old, could be orbiting right alongside us, hiding in plain sight. The concept took off after the discovery of Oumuamua in 2017, the strange, elongated object that came speeding through our solar system from interstellar space. It wasn't just its shape that caught attention, it was its behavior. As it passed the sun, Oumuamua accelerated, just slightly, but enough to puzzle astronomers. It didn't have a visible tail like a comet, and its trajectory didn't match what we'd expect from gravity alone. Some scientists suggested it could have been pushed by solar radiation, a natural process. But others, including Harvard astronomer Avi Loeb, proposed something more daring. What if it was an ancient probe, a fragment of alien technology, built with a light sail thin enough to catch starlight itself? Now, that's not proof, and most in the scientific community still lean toward natural explanations. But it opened the door to a much larger question. How many other interstellar objects pass through our system every year? Recent surveys suggest the number could be millions. Most are small, dark, and silent, but among them, a few might not be entirely natural. Think about it. A civilization that reached interstellar capability billions of years ago could have sent out self-replicating probes, machines designed to explore, observe, and persist. Their creators might be long gone, but the probes wouldn't have to be. Drifting for eons, disguised as harmless rocks, they could outlast everything. They wouldn't need communication or maintenance, just a mission embedded in their design: survive, collect, watch. In 2023, astronomers even noted a few near-Earth objects with unusual metallic spectra. Not quite asteroids, not quite space junk. We don't yet have the resolution to say more, but the thought lingers. What if we've already captured alien artifacts in our data, only to label them as space debris? It changes the entire question, doesn't it? Instead of asking, where are they? We might have to ask, have we already seen them and just not recognized what we're looking at? And maybe, just maybe, we already have. Because if there's one moment that still echoes through the history of SETI, it's what happened one night in 1977. A single blip, a narrowband radio signal that lasted just 72 seconds, strong, clear, and coming from deep space. When astronomer Jerry Amon saw the printout, he circled it in red ink and scribbled one word in the margin: wow. That's how it became known, the WOW signal, the forgotten message from the stars. For decades, scientists have tried to explain it away: a satellite, a comet, some kind of interference. But every time they've checked, those explanations fall apart. The frequency, 1420 megahertz, sits right at the hydrogen line, a sort of cosmic quiet channel that any intelligent species might use for interstellar communication. It's like sending a message on the most universal frequency in the universe. The WOW signal was never repeated, and that's part of what makes it so compelling. If it were a glitch, you'd expect to see it again. If it were a deliberate signal, maybe it wasn't meant for us at all. Maybe we just caught the edge of a broadcast meant for someone else. Follow-up scans of the same region have turned up nothing, but some researchers have pointed out faint anomalies, slight upticks in radioactivity, tiny bursts that could hint at a long-period beacon. Maybe it's repeating once every few decades. Maybe it's buried in the background noise, waiting for technology sensitive enough to hear it again. The strange thing is how easily it was forgotten. The wow signal should have changed everything. Yet it became a curiosity, an old story buried in textbooks. But what if that's the point? What if it was a message, but not one we were meant to understand right away? What if it was a signal meant to test who's listening and who remembers? Because if the dark forest hypothesis is true and civilization stays silent out of fear, then sending a signal at all might be a test of courage. And if the estivation hypothesis is true, maybe the ones who sent it are sleeping now, waiting to wake again. And if the relic theory holds, maybe the message wasn't just sent across space, maybe it was left behind in physical form somewhere much closer than we think. Each of these ideas, the ruins of dead civilizations, the hidden probes drifting among us, the ghostly signal from 1977, they all start to paint a single, unnerving picture. That maybe we're not alone, and maybe we never were. It's just that the universe isn't broadcasting in ways we recognize. Its stories are told in dust, debris, and one fleeting whisper caught decades ago. And as we uncover more piece by piece, the question begins to shift again. Maybe the real mystery isn't whether they exist, but how much of their presence we've already missed. As we move from signals drifting through space and ancient relics of civilizations past, another set of possibilities opens up, this time hidden beneath the ice and in the fundamental principles that govern life itself. These are the quieter hints, the subtle possibilities that demand we look not just at the stars, but at the planets, moons, and the very logic of life in the cosmos. The hidden ocean worlds hypothesis beneath the frozen surfaces of moons like Europa orbiting Jupiter or Enceladus circling Saturn, vast oceans may exist, completely sealed from the light of their parent stars. It's a strange notion to consider, life thriving in total darkness, yet our own oceans on Earth provide a compelling blueprint. Deep-sea hydrothermal vents host ecosystems independent of sunlight, fueled purely by chemical energy. Could similar processes support alien life under kilometers of ice elsewhere in our solar system? Robotic probes like Cassini have already given us tantalizing clues. Plumes of water vapor and complex organic molecules erupting from Enceladus suggest active chemical processes beneath its icy crust. Europa, with its magnetic field interactions, hints at a global ocean under tens of kilometers of ice. These aren't just static bodies of water, they are dynamic, chemically rich environments. The conditions for life are arguably far more stable and persistent than on exposed planets where radiation and temperature swings are extreme. If life does exist there, it may never interact with the surface. Submerged in perpetual darkness, these creatures would leave almost no detectable traces, at least not by the methods humanity currently uses. This hypothesis challenges our search strategies. We are looking for signs of life where sunlight reaches, but what if the majority of intelligent or complex life lies hidden beneath icy shells? And if one day we do find microbial or even multicellular life in these hidden oceans, it might shift our perspective on what life can be and where it can thrive. Transitioning from oceans hidden beneath ice, we confront a principle that stretches across galaxies and time itself, one that argues we should expect life to exist elsewhere because the universe does not favor Earth alone. The cosmic mediocrity principle. This principle is elegantly simple. Earth is not special. Humanity is not privileged. Life arises wherever conditions allow it. This isn't speculation, it's a framework derived from centuries of astronomical observations. The Copernican principle dethroned our planet from the center of the universe. Today, missions like Kepler and JWST are revealing billions of Earth-like planets orbiting ordinary stars. If the universe has so many potential habitats, why would life be unique to Earth? This principle reframes the Fermi paradox. The silence we perceive, the absence of obvious contact, does not indicate emptiness. It reflects the vast scale of space and the staggeringly low probability of overlapping civilizations encountering each other. Life may be common, but intelligent life may still be rare, dispersed across light years, evolving at different timescales. When we consider the sheer number of planets and the universality of chemistry, it becomes hard not to assume that somewhere out there, life is evolving in ways we might recognize, or fail to recognize entirely. The cosmic mediocrity principle is more than a philosophical stance. It's a lens through which every signal, every discovery, every anomalous observation must be interpreted. If we see evidence of complex chemistry, active geology, or even a single amino acid in an exoplanet's atmosphere, this principle suggests that it could indicate life is emerging, quietly, independently, and perhaps everywhere. And as we connect this to what we already know of hidden oceans and distant planetary systems, the framework of possibility grows exponentially. From general principles and theoretical probabilities, we shift into a hypothesis that crosses history itself, suggesting humanity may have already brushed against the presence of alien intelligence. The ancient contact hypothesis. This theory proposes that humanity's past may already contain evidence of extraterrestrial visitation. Across disparate civilizations, there are recurring motifs, beings descending from the sky, imparting knowledge, or influencing culture. Ancient carvings, monuments, and astronomical maps sometimes display levels of sophistication that seem out of place for their era. Could these be indirect traces of contact? Skeptics often argue that these are coincidences or misinterpretations, but when similar patterns appear across continents with no known contact between cultures, the question becomes more compelling. For instance, structures like the pyramids, megalithic sites in Europe, and the astronomical alignments in Mesoamerican civilizations display a precision that some researchers argue could have been guided by external knowledge. Not proof in the strict scientific sense, but enough to spark questions that push us to reconsider the limits of ancient human knowledge. Ancient myths and texts, when reinterpreted under this lens, start to resemble encoded accounts of real events. Beings in the sky, fire raining from above, knowledge of star systems far beyond what was achievable with contemporary tools. These descriptions could be symbolic, but they could also hint at contact so long ago that it has been woven into culture as legend. And when you consider the implications, it's striking. Life in hidden oceans, the statistical inevitability of life across countless planets, and ancient whispers of contact. They all converge on a single, unsettling idea. The universe may be teeming with intelligence, yet much of it remains invisible to us. We may already have been touched by it in ways we have yet to fully comprehend. And so, when we step back and look at the bigger picture, what emerges is both humbling and exhilarating. Across icy oceans, distant planets, hidden signals, and ancient traces, there's a persistent whisper that intelligence may exist far beyond our reach, sometimes subtle, sometimes obscured. The universe doesn't announce itself in grand gestures. It hides its secrets in patterns, anomalies, and fleeting hints, leaving us to piece them together with curiosity and patience. It's not just about life as we know it, or signals we can immediately detect. It's about the possibilities, the threads connecting distant worlds, the echoes of civilizations long gone, and the potential of life in forms we can barely imagine. Every discovery, every unusual pattern, every fleeting signal nudges us closer to understanding that we are part of a much larger story. Perhaps the universe is not silent. It's simply speaking in a language we're only beginning to learn, inviting us to keep searching, questioning, and imagining the countless ways we might not be alone.